Hi everybody, it's Mrs. Silvering again. Today we are taking what we learned in arithmetic sequences and extending it into another topic called slope and rate of change. But you're going to see it's pretty similar. Please open up to page 17. So first question says, how can you write an equation of a pattern if the x's don't go up by 1? So let's see, we can think about this. One way to do this would be we could extend the pattern and fill in the blanks. So I'm going to write in what we have. I guess I'd have to go all the way down to 8. Well, I'm going to stop right there because it's a little bit lengthy. So could we fill in the blanks? So let's see, I could certainly fill in the x's. 1, 2, 3, 4, 5, 6. I'm just going up by ones. And let's see, could we think about how could we fill in the blanks? So in my mind, I'm thinking what's between 5 and 10 for the same reason that 3 is between 2 and 4. So halfway between 5 and 10 is 7.5. Halfway between 10 and 15 is 12.5. So let's see, my pattern looks like I'm going up by 2.5 each time. Therefore, I could go down this way as well, and that would be down 2.5. So just like before, we could figure out the equation. Our starting point is 2.5, and I'm going up by 2.5 each time. But there's got to be a better way to do this because this is kind of cumbersome. So what if we thought over here? Each time my y's go up by 5, what do my x's go up by? They go up by 2. So if we think about this, for every 5 that we go up by y, we go up by 2 on the x, and 5 over 2 is 2.5, same as here. I'm sorry, I should have written plus 2.5 as well over here. So let me say that one more time. Every time we go up by 5 in the y's, the x's go up by 2. It is the same number as if we went up by ones. So we have a word called slope, and slope has to do specifically with points, but slope is, I'm sorry, let me make my pen a little bit smaller. And I'm just going to erase this little bit here, but hopefully you have that. Okay, slope is the change in y over change in x. Just like in arithmetic sequences, just like in patterns, we're saying how much are we going up by y, and then we divide it by how much are we going up by x. There is an abbreviation that we can use. Change in is represented by a triangle, which is the Greek letter delta. And so what I will often write is delta, but it's change in y over change in x. Rate of change is the same thing as slope. It is used more specifically for any applications. I'm going to say used for word problems. So we might say miles per hour, or what is your hourly rate? Okay, lots of applications, but it's ultimately the same thing as slope. So let's move to the middle of the page. So finding slope from a table. you'll see that this is similar to what we did, only we're not going up by ones, we're going up by different amounts. So let's go first by the y. And we can write on the bottom, slope equals change in y over change in x. So what's my change in y? Down 2, down 2, down 2, down 2. How about x? Up 3, up 3, up 3, and up 3. You really don't have to write that every time. So slope is very simple. It's the change in y over the change in x. Negative 2 over 3. Let's do the next one. Slope is change in y over change in x. So let's see, I'm going up 10. Now how about the x's? Look carefully. I'm going down 2 each time. Change in y over change in x. We typically reduce, so this will be negative 5 or negative 5 over 1. You'll see in the future it's actually easier if you write it as a fraction. Okay, and I'm, let's see, running out of a little room on my screen here. Okay, I'm going to have to write close. So up 5, up 5. Okay, same pattern. Slope, let's see if I can write without. Change in y over change in x. So 5 over 5, 1 over 1, or simply 1. And let's do one more method on this video, which is finding slope from a set of ordered pairs. So find the slope of a line that goes through the points 4, negative 7, and 6, negative 1. So remember what we said, slope is change in y over change in x. It might make sense for you to make a tiny little table here. 4, negative 7, 6, negative 1. All we need is one single point. Two sets of points. I really said that wrong. 2 sets of points. What we need is one change. I'm going to write this in blue so that you can see because it is a little bit tight. So my y's are going up 6. My x's are going up 2. So my slope, 6 over 2, or 3 over 1. Let's do the same thing for number 2. Okay, again, I'm going to make a little table here because I think it's a little easier to see. So 0, 8, 4, negative 4. Slope, change in y over change in x. All right, let's think. My y value from 8 to negative 4 is going down 12. My x, so I'll write that, down 12. And my x value is going up 4. Slope is negative 12 over 4. You can bring that one down to negative 3 over 1. Find the slope, number 3. Find the slope of the line that goes through the points 5, 1, and 9, 4. I want you to try that one on your own, and I will pause it here. So, did you get 3 over 4 for your slope? If not, go back and try it again. Number 4 is a little bit different, so we'll do this one together. I'm going to write my points out again. So change in y from 2 to 2 is actually 0. There's no change. And then this is down 8. Slope equals change in y over change in x. 0 over negative 8. Doesn't matter what your denominator is. 0 divided by anything is 0. So I'm going to end this video here. and I will make another video for page 18.